Hello everyone, I am Suchita Mohril. Welcome you all in the video lecture on the topic Difference Equation with Constant Coefficient Part 4. In first part, we discuss PI case 1 whenever the right hand side of the equation is a to the power n. In part 2, we discuss particular integral case 2 whenever the right hand side is cos kn or sin kn. In part 3, we discussed the particular integral case 3 when right hand side of the equation is n to the power p. Now, in this video, we are discussing particular integral case number 4 whenever the right hand side of the equation is a to the power n into f of n. That means product of function of two functions of n. And here f of n is the polynomial in terms of n of degree p. In that case, we have to write down this a to the power n outside, and then this e is replaced by ae. Therefore, here 1 upon phi of ae into f of n, and then proceed as in case 3. Now we discuss problems on this. Consider the given equation, and this equation is difference equation with constant coefficients. Now we write down this equation in terms of E, and then its solution is given by CF plus PI. Now for CF, we write down auxiliary equation by substituting E equal to M in this term. Therefore, we get 4m square minus 4m plus 1 equal to 0. The roots are 1 by 2, 1 by 2. These two roots are equal. Therefore, apply here case 2 of CF. Here m to the power n c1 plus nc2, which is the required CF. Now for particular integral, here 1 upon function of e into, here we write down the right hand side of the equation in the form of 1 by 2 to the power n into n. Here product of two functions of n. Therefore, we write down this a to the power n outside, and then this e is replaced by ae, but here value of a equal to 1 by 2. Therefore, we replace this e by 1 by 2, and then we get this term. Simplify this. Now apply case number 3 for this. Now in case 3, we substitute the value of e in terms of delta, and n is write down in the form of factorial notation. That means n to the power 1 factorial. After simplifying the terms, we get 1 upon delta square n to the power 1 factorial. Now 1 by delta square is equivalent to integration whenever the values of n in factorial notation. Therefore, we integrate two times of this. One time integration is n to the power 2 factorial upon 2, and another integration is n to the power 3 factorial upon 6. Now we substitute the value of n to the power 3 factorial, and we get the required pi. Lastly, we write down complete solution. This is the value of CF, and this is the required value of pi. In this way, we solve the problem of fourth case. Now another problem here, consider the given equation, convert this in terms of E, gives equation number 1, whose solution is given by CF plus PI. For CF, we write down auxiliary equation by substituting E equal to M in this part. Then we solve this equation, find out the values of m equal to 8 and minus 1. The roots are real and different. Therefore, apply case 1 for writing CF. Then for Pi, here n into n minus 1, complete this value we consider as n to the power p, that means polynomial. 2 to the power n, that means here this is the a to the power n value. We write down this value outside the bracket, and e is replaced by 2e because the value of e equal to 2. And then simplify this. We write down in this e form, e square form, and then substitute the value of e equal to 1 plus delta here. After simplifying the terms, we get this shape. Now Taking lowest term common, now lowest term is minus of 18. Therefore, we write down this term. We write down this term in the numerator with negative index by taking negative sign outside here, and then expand by using binomial. Now here 1 minus of x term. Therefore, 1 plus x square and so on. Here n to the power 2 factorial. Here these n into n minus 1, we convert this in terms of factorial notation. Therefore, n to the power 2 factorial. Therefore, we consider the term up to del square. We simplify the terms, combine the terms of delta and del square, and then n to the power 2 operate by each term. And if there is delta, delta is equivalent to differential operator. Therefore, delta of n to the power 2 factorial is 2 n to the power 1 factorial, and its delta square value equal to 2. In this way, we substitute the values, then we convert into factorial notation form to algebraic form. N to the power 1 factorial is n to the power 2 factorial is n into n minus 1. We substitute these values here and combine the terms and write down the last answer. In this way, we solve the problems of fourth case. These are the practice problems. Here, a to the power n into n to the power p. Similarly, a to the power n into n to the power. Therefore, apply case 4. Thank you for watching this video.